Hello. In this short video, I'm going to talk about how you can use an angle encoder, which is this board here. So this IC is a magnetic angle encoder, which means it can measure the position of a magnet. So here you see there is a magnet stuck here, which is diametrically polarized. So once I place this in front of it, it can measure the angle of the magnet. Now that magnet, it is attached to this flywheel. Now, flywheel experiments are pretty common in mechanics labs, where often you want to find the moment of inertia of the flywheel. And this involves counting the number of rotations that the flywheel has made. So in the software, once you connect this to the SEELab device, you can go to scan and auto detect sensors. So it's detecting this magnetic angle encoder, and you say start measurements. Now here you can see that it is tracking the angle, which as I move it, you can see that it goes from 0 to 360. The second is the position, which is the cumulative angle. So it's just summing one. And the third is number of rotations, which is again basically the position divided by 360 as an integer. So as this keeps rotating, you can see that the rotations are going up. And now you no longer have to count this thing manually. You'll get a pretty precise count here. We can also go here and set this to 0. So this is, zero position. If you want to start from a particular point, not that it's very useful. Now let me go to the data logger. Let's restart this here and spin this. So you can see that as it's spinning, the angle keeps resetting and the cumulative angle keeps decreasing. If I just bring this back, you'll see that it will perfectly overlap the initial angle. Yeah, showing that it's repeatable. We're not missing any counts or anything there. And the red trace, of course, is the number of rotations. So I'll sort of have to zoom in here to see the number of rotations. So you can see that it increments with each rotation, each full rotation. Now, this encoder is particularly useful even for other experiments, such as your simple pendulum. I could have this magnet on the shaft of a pendulum where it rotates the pivot and, tracks the oscillations very precisely as a function of time. So let's say this is a simple pendulum. Okay, so it's going to oscillate like this, and if you want to find out the time period, all you need to do is hit pause here, select a reasonable section here and say sine fit. So this will fit it and it will tell you that the frequency of oscillations is 0.8 hertz. So it's pretty simple to do a lot of experiments, and in the future I plan to have multiple sensors like this to measure more complex setups. For example, a flywheel which is free to oscillate, with a counterweight, can be used to demonstrate precession. So the flywheel rotates, you give it a downward force, it starts precessing and rotating around. So that way it will be useful to have multiple sensors. So yeah, that's it. Thank you.